guy who made Mistcraft doesn't update
Kind of
anymore.
rings a bell, yeah.
And Mistcraft was really cool because it was actually like Mist, where you could like collect these little runes and then make books, and the books would actually create new worlds inside of them based on the runes you used.
Hell
If you
yeah.
didn't use runes to control it, it would be random. And I remember I made a world that was like this infinite milk and honey world that was like the surface was flowers and forests and like little ponds of milk. And then the one really cool feature was that for some reason all over this world, on the surface, was just a bunch of nether fortresses exposed on the rocks. Little bridges everywhere. And like it's like, huh. So just like I would go to that world to farm blaze rods. And then you could like make portals to like another world inside the world. So you just have these like infinite worlds kind of thing going on.
I can dig it. Sounds like fun.
Yeah, it's kind of neat. Like I had one world that I went to, it was just like a barren industrial wasteland hills. And I was like, you know what? I don't care about fucking up this world. So like I brought some automated mining blocks with me, and I took 3 chunks that are like whatever 16 by 16, and I like cut them all down to bedrock in a row, making a rectangle. And then I like built the one on the one side back up to the top level of surface. And I built like a little castle on that chunk,
Really?
on the top of it. And then I built like my tower in there. And then I used the other 2 chunks that were open, like an open skylight inside the like tower that was like, yeah. You can do some fun stuff with mods if you're just doing it for the fun and the aesthetics. So being like,
Oh, yeah.
I'm gonna become a blood mage, so I have a blood mage pyramid over here and this and that, and just play for a month or something.
Where did that bat go that I killed? Weird. Okay, alright, I got homies coming to see me, I think. No, he's just having a really weird patrol. Okay, what? I'm very confused. Why is this guy taking 30 hits to go down? Okay, Jesus. Okay. Reset a little bit here. Okay. I'm gonna play myself a little song and have a little nap. This will be a good opportunity to go sneak and use the restroom here. Oh, I didn't put my video up anyway. Big rip. Man, they just changed the rate at which you heal. And it is really slow before you get stats. Not fantastic. range over here? No. Let's see. I can. Oh yeah, he's gonna come say hi. That sucks very bad, actually. Walk through that fire there, buddy? Okay, cool. I don't have a ranged weapon. Let's see. Chilling. Sometimes. So what's this? That does mean it's in the next pack. Wasn't sure. Good to know. Static around here. Appears as though homeboy did not either didn't notice me or doesn't really care. I am perfectly content to wonder if that wizard was solo though. To do it again. I've been stealing these portals. No shot. Somebody has to go for that. do.
「
very small amount of money, but money nonetheless. Here. The agi is good. Oh wait, no, it's dexterity that's good for me now. Does my regular interaction speed? That's the duration. See, the manual dexterity thing is throwing me off because I'm pretty sure these made me way faster at playing. But maybe I was just hallucinating, or maybe it's bugged. Okay. Let's see. Restream. Just double check this. Okay. And so this way I can go to so I can see the chat. Okay. I still have my one dedicated viewer. Amazing. Truly magnificent. Okay, let me... I guess let's go to the... I think Red can play these. She should be able to, at least. I wonder if she could do... Okay, well let's do this, that, this, this. There we go, now I can pretend I'm being productive. Do I have a... Okay, there's just one sitting there.
G'day everyone, good to see you all. Today I'm here to tell you how to harness the power of local LLMs using our Rust library. Quick intro, I'm Mithun, as you just heard, but I go by Philpax Online. I hail from Australia, hence the accent, but I live in Sweden. I do a lot of things with computers, but my day job is at Ambient, where I build a game engine of the future. Today, though, I'm here to talk to you about LLM.rs, a Rust library that I maintain. So, LLM.rs, or LLM between friends, I realized that after disambiguate when I signed with Simon's newsletter. It's an all-in-one solution for local inference of LLMs, but what does that actually mean? Well, most of the models we've discussed at this conference have been cloud models. Your ChatGPTs, your Claudes, your Bards. Local models offer another way, where you own the model and it runs on your computer. So let's quickly go over what that actually means. First up, size. Model size can be used as a rough proxy for the intelligence of the model. Most hosted models are really, really big. You can see that it's dominating the right-hand side of the chart there. You have your GPT-3, your GPT-4, we'll get back to that, your Go for your Palm 2. These are all insanely big in comparison to the open source models we have.
Oh shit.
We're beginning to see some bigger
I
models
forgot to buy pods.
Llama
Yes,
and
I did.
Falcon,
Amazing.
but even they pale in comparison to what the
well,
bigger
this is
players
not
can
gonna
do.
go well.
This means the local models don't have the same capacity for intelligence. However, a smaller, more focused model may be able to solve problems better than a large general model. By the way, we don't actually know what size GPT-4 is. That's rumors. Only OpenAI knows. Next, let's talk about speed and capacity. Cloud models run on specialized hardware with special configuration. Local models run on whatever hardware you can scrounge up, including rented hardware. The further up the axis you go, the more speed and/or parallel inference you can do, but the more inaccessible it becomes. This end, a few $100s. That end, a few $100 million. Next up, latency. Cloud models need the full prompt before they can start inference, and you have to wait for the message back and forth. Local models can give you a response immediately. You see the prompt as you go along. This is very important for conversations where you want the model to be able to process what you're saying as you say it. And of course, you can't escape talking about cost. The cloud vendors will charge you a per token price. When running locally, it's entirely up to you how much it costs you to run the machine. If the running cost of your model is less than the cost of running your workload to the cloud, you're going to make a profit. And if you're running on a machine you already own, well, that's basically free, right? With the cloud, you have to use the models they offer you. Some vendors offer fine-tuning, but they often charge more than just using the regular model, and they often charge you for the process of actually fine-tuning. This means it's not often cost-effective to actually do that. With local models, the sky's the limit. There are hundreds, potentially thousands of custom models that can suit any need you have. Knowledge retrieval, storytelling, conversation, tool use, you name it, someone's probably already done it. And if they haven't, fine-tuning the existing model for your own use is easy enough. Which makes it easy to fine-tune our models with any option. And, of course, privacy. There are some things you don't want to ask the internet. Local models let you privately embarrass yourself. Now, you might be wondering how it's actually possible to run these models locally. That, my friends, is possible with the power of quantization. If each model is billions of parameters, and those parameters are like individual numbers, how could you possibly run them on consumer hardware when there's only so much memory available for a given performance level? Well, we can use quantization. Quantization lets you lossily compress a model while maintaining the majority of its smarts. We can take the original model, here in blue, and switch it down to something much smaller using one of these green formats. This is the secret sauce that makes it viable to run models locally. Smaller models aren't just easier to store. They can also run faster as your computer can process more of the model at any given moment. But that's enough about local models. You've probably already heard much of that already. Let's talk about the actual library. It all started with this man, who built something you may have heard of. Of course, I'm referring to CDP. Look at the mere 98 stars. How pedestrian compared to today, what 43,000 stars? When I saw it, I had but one idea. It's time to rewrite it and things. Well, I said I wanted to do it, and I did.
Works better when you lean
to
back.
the right here, Sector 22, was also working on the same problem. And, well, there was just one catch. He beat me to it, completely beat me to it. I'm not afraid to admit it. Luckily, we came together, managed our projects, and I ended up as the maintainer of the resulting project, and that's how LM was born. So, you might be wondering, why? If Llama CPP exists, why use LMRS? Well, with LM.RS, I had 6 principles in mind. It must be a library. When I first started in March, Llama CPP was not a library, it was an application, and that made it impossible to reuse. It must not be coupled to an application. You must be able to customize its behavior. You must be able to go in and change every little bit of it to make it work for your application. And you shouldn't make any assumptions about how it's going to be used. It should support a multitude of model architectures. Of course, Llama CPP supports Llama and Falcon, but clearly there are more out there. Next up, it should be Rust native. It should feel like using a Rust library. It shouldn't feel like using a library with binding, and it should feel like how you expect a Rust library to work. Next up, backends. It should support all possible kinds of backends. You can run on your CPU, your GPU, or of course your ML-powered toaster. I'm sure it's going to be a thing, but we were going to see it coming. I swear. And finally, platforms. It should work the same whether it's on Windows, Linux, macOS, or something else. You shouldn't have to change it significantly to make it work, because deployment has always been an issue. Today, I'm proud to say we support a myriad of architectures, including the darlings of the movement, Llama and Falcon. These architectures all use the same interface, so you don't have to worry about changing your code to use a different model. This is made possible by the coordinate efforts, my co-contributors, Lucas and Dan, who couldn't have done this without, as well as many others. Here's some sample code of the library. I won't go too much into it because it's quite dense, but the idea is that you load a model right over the top because it's actually quite small, and with that model you create sessions which track an ongoing use of the model. You can have as many of these as you would like, but they do have a memory card, so you want to be careful. Once you have a session, you can pass a prompt in and infer with the model to determine what comes next. You can keep reusing the same session for conversation. You don't need to keep repeating the context. The last argument of the callback is the callback. That's where you actually get the tokens out. It's worth noting that the function itself is actually a helper. All it does is call the model in a loop with some boundary conditions. So if you want to change the logic in some significant way, you can. We're not going to stop you from doing that. One last thing about this, though. You see all the calls to default there? Those are all customization points. You can change pretty much anything about this. You can change how the model is loaded. You can change how it'll do the inference. You can change how it's handled. The entire point is you have It's reasonably fast, but it could be faster, right? Thanks to the power of GPU acceleration, we have something that's much more usable. And believe me, it's even faster than Intel GPUs, AMD and Intel support pending. Now let's talk about what you can actually do with the library. Let's start with the community project to begin with. First, you've got Local AI. Local AI is a simple app that you can install to do inference locally. There's nothing magical about it, it's just exactly what it says. I think that's really wonderful because it means anyone can download this app and get ready, be able to use local models without even thinking about it. Next up, LM chain. It's LangChain but for Rust, and of course it supports inference with the library. And finally, we have Flowchat, which is a flowchart-based application where you have your own workflows. I think we've seen a few of those in this conference, and you can combine nodes to build the workflow you need. And of course, it supports the library as an inference engine. Now, I wouldn't be a very good library author if I didn't actually test my own library. So I'm going to go through 3 applications. The first 2 are proofs of concept. The first is LM Code. It's a Discord bot. You can see it's exactly what you'd expect. You send a prompt, it'll give you a response. Any hitches you see come from Discord limits, not from the actual inferencing itself. You can see, bam, all there. When you issue the request for generation, it goes through this process where the request goes through a generation thread. That channel is then used to create a response task, and then responders will send the responses to the user. Now, the interesting thing is, These sessions are created and thrown away immediately with each query, but you don't need to do that. If you keep them around, you can actually use them for conversation. And just to illustrate, this is just like the request response workflow you would use for anything. If I just take what I had there, I drop the Discord bit and add in HTTP, you can see request, generation, response. Easy. Next up, Alpa. I love using GitHub Copilot, but it's only available in my code editor and it requires internet connection. Alpa is my attempt to solve this. It is autocomplete anywhere in your system, just by taking what's left of your cursor and having a model to type in. And of course, you can use any model, including a model fine-tuned in own writing. Ask me how I know. Alpha is also quite simple. In fact, it's so simple I don't really need to cover it. Listen for input, copy the input into a prompt, start generating, type out response. Easy. Now, the first two examples are pretty simple. They're proofs of concept. But now I want to talk about an actual use case. This is a real-world data extraction task. Over the last few years, I've been working on a project to make a timeline from the dates of Wikipedia, because there are millions of pages and they all have dates, and you can build a world history from it. However, these dates are often unstructured, and more or less not the past using traditional means. Like, yes, you can using regex to extract the dates, but you can't get the context out in any meaningful sense, and there are some dates here that just don't make any sense at all. So, that's why, as being in the conference, I just
Too shabby.
however, 2, 3, and 4 aren't perfect, even after rounds of engineering. So yeah, I tried here, and handling millions of days is just too expensive and slow. So I decided I'd find my own model. I generated a tool to go through the data set, so pick out any data point, fix it up, and then correct the errors, build a new data set, and train a new model. So I did that using Axolotl, which I mentioned earlier. Again, check out Axolotl for all your fine-tuning needs. Highly recommended. And now I have a small, fast, consistent model that can pass any data to, any date to, and get back a structured representation, which I can, of course, immediately pass using Rust. And I can treat that as a black box. So I have a function there, fnPass, pass some dates, get some dates back. Simple. Now, let's quickly talk about the benefits of using local models and the library. First off, deployments. Show of hands, who's had to deal with Python deployment hell? Dependency hell, even. Yeah, I know, it's awful. You spend hours just trying to sort out your conda, your pip, your pipenv, it's awful. With the library, you inherit Rust's excellent cross-platform support and build system, making it easy to ship self-enclosed support binaries to your platform. No more on making your users install Torch. As you might imagine, this unlocks the use of desktop applications with models. Next up, the ecosystem. Rust has one of the strongest ecosystems of any native language. You can combine these libraries with LLMs to build all kinds of things. It's what let me build a Discord bot, a system of completion utility, a data ingestion pipeline with a dataset, a utility explorer, all in the same language. And I think if you use LLMRS, you can do the same thing with your house as well. Of course, you also have control over how the model generates. I alluded to this earlier, but you can choose exactly how it samples tokens. Normally, when you use a cloud model, you have to get back the
I am gonna take off for the evening, but thank you for coming by to show your
and that's slow and expensive.
support for my endeavors.
You directly control what you are
I've
sampling.
been almost through a whole month of cataloging messages.
Finally, let's talk about the innovation in space. If you're here, you probably know there's a paper almost every single.
Yep, you too, buddy. Catch up.